Hello students, here let's see rotation about an arbitrary point. Now, an algorithm for rotation of an object x about an arbitrary point p x1 y1 through an angle theta. Suppose we have to rotate the object x about an arbitrary point p x1 y1. In 2x2 transformation, we have written a rotation matrix of rotation for it is a rotation about origin. It is a standard rotation. Now here, this is any arbitrary point in plane. Through that point with an angle theta, we have to rotate an object. Okay. So here, what is the algorithm? Actually, first of all, we will translate this point P at origin. Then rotate it. As we translate the point, that time the object is also get translated, right? Again, later on we will rotate it through an angle theta, whatever the theta given to us, and then apply inverse translation. Then it will go to the new position. Now let me show you figure for that. Here, look at the figure. Here the point P, okay, having a coordinates x1 y1. Here our object x is given. Okay, this is its original position. Now the translation is applied. As I say, we will translate this point P at origin. We have to translate it to origin. So translation is applied. The point P will come at origin. Origin and P are same. So due to that, the object is also get translated. So object comes here. Okay. Now we have to apply rotation through an angle theta. So we will rotate it in anti-clockwise direction. So after rotating, the object will come here. The point P remains at the same position. Okay. Now we will apply inverse translation. So applying inverse translation, the point P will goes and then object also come here. Okay. According to that, object will come here. Okay. As such, the matrix of transformation will be obtained with these combined transformations: translation, rotation, and then inverse translation. Using that, the concatenated transformation matrix will be obtained and apply it on x. We will get the new position or the new object, which was obtained after rotation about this point P. So now let's write the steps of algorithm. First, consider P x1 y1 and translate it to origin. O 0, 0 using translation matrix. Which was the translation matrix? 1 0 0 0 1 0 minus x1 minus y1 and 1. The point P will translate to origin. Then second, as P coincides with origin, along with point P along with point P points on the object are also translated. Points on the object are also translated. Rotate it about origin through an angle theta using a matrix that will be r theta. Suppose that matrix is cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. Third step, this rotated object along with point P is back translated using inverse translation matrix. And that will be inverse translation will be here now inverse of it. So 1 0 0 0 1 0, here x1 y1 1. Now this multiplication of these three will give us the concatenated transformation matrix. Therefore the concatenated transformation matrix is T equal to translation into rotation into inverse translation. Using homogeneous coordinates of object X, we get X star equal to what? X into T. This is an algorithm. Now let's see example on this. Example, rotate the line segment between the points A 1 2 and B 3 6 by an angle 90 degree about the midpoint of line segment AB. Solution, we have seen just the algorithm, so we have to rotate this line segment AB about this midpoint through an angle 90 degree. So this rotation is about midpoint of A12 and B36. Okay, so what is the midpoint here? Therefore, midpoint of AB, midpoint of AB is what? This is x1 plus x2 upon 2, y1 plus y2 upon 2. That will be 2 and 4 here, 2, 4. Okay, now according to algorithm, to rotate about this 2, 4 through 90 degree, we use first translate point 2, 4 to origin. That is what? 0, 0. Okay. Second, rotation about origin through an angle 90 degree. This translation using TR, this rotation using R theta, right? And third step, inverse translation. So inverse translation using TR inverse, right? This one we have to do. Therefore, concatenated transformation matrix is T equal to TR into R theta into TR inverse, and that will be TR, matrix TR is 1 0 0 0 1 0 minus 2 minus 4 1. R theta will be cos 90 0, sin 90 1 0, minus sin 90, so minus 1, cos 90 0 0 0 0 1, right? Again, inverse translation will be what? 1 0 0 0 1 0 2 4 1, this one, right? So now resulting transformation matrix will be, the product of these three is 0 1 0 minus 1 0 0 6 2 1. This is the concatenated transformation matrix. Therefore, transformed line segment is what? This transformed line segment will be A star B star equal to what? AB into what? T, right? So therefore, what is A star B star? Equal to AB. What is AB? here we need to use homogeneous coordinates. Remember, A having coordinates 1, 2 and homogeneous coordinate 1 we are using. B having coordinates 3, 6 and 1 we will use, and into T 0, 1, 0, minus 1, 0, 0, 6, 2, 1. And this gives us a new transformed line segment that will be having coordinates 4, 3, 1, 0, 5, 1. This is the answer here. This gives A star having the coordinates 4, 3 and B star having the coordinates 0, 5. You can check these things on in two-dimensional plane using the graphs. Okay. Next example. Rotate the line segment between A 2 minus 5 and B minus 6, 11 about its midpoint through an angle pi/4 radian. Again, just like a previous question, this rotation is about midpoint of AB, where A is 2 minus 5 and B is minus 6, 11. Therefore, midpoint of AB is what? It will be 2 minus 6 by 2 means what? It will give us minus 2 and here we get 3. x1 plus x2 upon 2, y1 plus y2 upon 2. This is a midpoint formula, right? Now, to rotate AB about this point, right, we use first step, translate this point minus 2, 3 to origin. Origin using translation matrix, right, according to algorithm. Then rotation about this, rotation about what? Origin through an angle, this pi/4 radian using r theta. And third, inverse translation using okay, therefore concatenated transformation matrix is T equal to TR r theta into TR inverse. So translation matrix is what here? 1 0 0 0 1 0, and this is 2 minus 3 1. Then rotation is cos of 45, it is 0.707, sin 45 0.707, 0, this is minus 0.707, this is again 0.707, 0 0 0 1, and inverse translation 1 0 0 0 1 0 and minus 2 3 1. Okay, this product will give the transformation matrix concatenated, and that will be 0.707, again 0.707, 0, minus 0.707, 0.707, 0, this is 1.5355, this is 2.2929 and 1. Now we have to apply it on AB to get transformed line segment. Therefore, transformed line segment is, the transformed line segment is what? A star, B star, that will be AB into what? T. And that is, what is AB? It is 2 minus 5 1, right? Point A, and point B is this. So minus 6 11 1. Using homogeneous coordinate we should write. This is 0.707. This is minus 0.707, 0.707, 0, 1.5355, 2.2929 and 1. This will give us the answer. The new coordinates are 6.4845, 0.1719, 1, minus 10.4835, 5.8279, 1. Therefore, A star having the coordinates 6.4845, 0.1719, and B star having coordinates minus 10.4835, 5.8279. Okay, now next thing we have to see reflection through an arbitrary line. So we will see that one in next video. Thank you.